Well, hello everyone. First of all, don't forget to like and subscribe. And in today's astronomy, what if? It's not going to be a what if. It's going to be astronomy fact, astronomy information. Regardless, I'll think of a name later. But in today's video, I want to talk about the moon. Simply because there's a lunar eclipse coming up, and I think the moon, even though the moon is probably, I believe, the most observed astronomical object that we that we are aware of. Well, not that we are aware of, but I want to give the moon some love for this lunar eclipse. First of all, as you can probably see, the first thing I'm trying to show is how far the moon actually is. And if you don't realize, the moon is actually pretty far from Earth. It's about, on average, and I use average because you're about to find out why. It's around 238,854 miles. And for those who use the metric system, 384,399 miles. That is pretty far. That's amazingly far. And you'll see, get some idea of how far it is because I'm about to zoom out to show where the moon is. And you can see it takes me a while to get the moon actually on the screen. Now, another interesting fact about the moon is that it takes the moon about 29.5 days, not exactly a full month, to go around the sun. I mean, not around the sun, I'm sorry, to go around the Earth. And what's amazing about the moon is that it's tidally locked to the Earth. Now, what do I mean by that? Well, if you look up at the moon, you notice that you see the same face or the same side of the moon all the time. And what tidally locked means is that the Earth's gravity has influenced the moon so much that its rotation and its orbit is influenced by it. And you can see in the video, what I'm trying to show the same face of the moon to the Earth. And I'm trying to show what it means by tidally locked. Because the moon is actually rotating. It's still rotating on its axis. But it's been synchronized with the Earth's orbit. And therefore, as it goes around the Earth, it's rotating at the same time. And therefore, from the Earth's perspective, and you're looking at the moon, it looks like the moon isn't rotating, but it is. And that's a small explanation of what tidally locked means. But another interesting fact about the moon is that the moon, so the planets orbit around the sun, what's known as the ecliptic. Similar plane that all the planets are on. The moon does not operate that way. If you notice, the moon can be in different locations in the night in the sky. And the reason for that is as the moon orbits around the Earth, it's actually going up and down, going a little out, going a little in. And you might be wondering, well, why is this important? Well, this is important because another interesting fact about the moon leads to why do eclipses occur? Because if you think about an eclipse, well, before I get to that, when you see in the video that you will see the moon actually going up and down as it orbits the Earth. But how does the moon play in eclipses? Well, compare the size of the sun to the moon. Obviously, it shouldn't be possible for the moon to be able to completely cover the sun. But it does. And the reason for that is it's actually an interesting math equation. Not complicated math, but the sun is 400 times the size of the moon. But it's also 400 times farther away. You add all that up, from an Earth perspective, that's why the moon and the sun looks like they are the same size, because size and distance. What's amazing about this is it leads to wonderful opportunities to see the moon cover the sun. Now you might be wondering why this is important. Well, you can see on this next simulation is you are seeing the moon's shadow going across the North American continent. This was the April 2024 solar eclipse. Now, if you have never seen totality, I'm not talking about when moon cover parts of the sun, depending on where you are. If you've never seen totality, I highly recommend you see it, because I have. And what happens is that you will see the moon's shadow moving towards you. You will see animals act strange. You will see people act strange. When the moon covers the sun, you will see planets. You will see stars. This actually was a help to prove, I believe, Einstein's theory of general relativity. But in addition to that, you will also be able to see the corona, which is the sun's atmosphere. And if you imagine waves in the ocean, that's what it looks like. Light waves moving in and out like waves in an ocean. Such a surreal, wonderful experience. So I highly recommend that. But anyway, the reason the orbit and the moon size all plays into this is because you will notice that, or you probably remember, the shadow of the moon and where it hits the earth, when it hits the earth, is different for each eclipse. And that plays into the orbit and where it is and where the earth is in comparison to that. But also it plays into the type of eclipse. So there's totality, which is a total solar eclipse. But there's also annular eclipses. And what happens with that is, as you've seen for a couple of minutes ago in the video, the moon goes up and down, it goes in, goes out, and sometimes everything, the moon, earth, and sun line up, but the moon is a bit further out. And therefore, it's unable to completely cover the sun, because instead of 400 times distance, it might be 350. I'm just making up that value. But that means the moon's a bit further out. It's a bit closer to the sun. Can't cover it up. And therefore, it'll still go across the sun, but it will be an annular eclipse. But those are some interesting facts about the moon. The last fact I just want to say is that it's theorized that the moon was created between a collision between Earth and the planet Theia. That's still theory, but that's the primary theory. But anyway, I hope you enjoyed the video. It was just little facts about the moon, and I will see you again.